use variational parameters to solve the given system. So here's the steps you need to do when you use variational parameters method. First, you need to find a homogeneous part, then find non-homogeneous solution and add them together, which gives you final answer. Okay, so here's the steps. It's not step-by-step process, but I will walk you through it when we work on a specific problem. Okay, let's put this aside. So for this specific problem, first thing is you need to have a minus lambda I. Okay, the reason I didn't have it down here because I'm familiar with it, so that's why I didn't put it out. But for some of you, I need to show it in case you don't know what I'm talking about. So let's call this matrix A and then subtract it with lambda I. That gives you this matrix. Then for its determinant, you will get this. Set it equal to 0. So for lambda, you will get complex eigenvalues. Now for lambda equals positive I, plug it into A minus lambda I. It gives you this matrix augmented with 0. From the first equation, I know that I k1 is equal to k2. If I choose k1 1, then k2 is I, and my vector k is 1 I. Then now I'm ready to write my homogeneous solution. So it is equal to c1 times the real part of vector k, which is 1 0 times cosine t. Why cosine t? This is actually cosine 1t, and where do I get the 1? So this 1 is coming from the imaginary part of lambda. Okay, and then minus imaginary part of vector k, which is 0 1 times sine t, or multiply by e to the 0. Why e to the 0? Because why e to the 0 t? This 0 comes from the real part of lambda, which is 0. Okay, so that's why I didn't have it down here, but according to the formula, it is e to the 0 t. And since this is complex eigenvalue, once you know the first answer, your second answer is easily to obtain. So you have C2 times duplicate this one, and then you have the opposite side here. Cosine side stay the same, and for the vectors you swap their order. Okay, so bring this over here, bring this over here. That gives you your second answer. And if you work further, multiply this in and then simplify it, it will give you this one. Similarly for this one, it will give you this matrix. Then you have it very nice and neat and nice. Okay, now for non-homogeneous part, first you need to have phi of t. Okay, so this matrix obtained from the homogeneous solution, and basically you just exclude C1 and C2, then write down the rest. So from here, I need first thing is to find the determinant of phi of t, which gives me 1. Then phi is inverse, which is equal to 1 over the determinant times this matrix. But you need to change something. So in the upward diagonal line, multiply by -1. Okay, in the downward diagonal line, switch their position, which is the same thing. Okay, so you will get this matrix. Then you need to find u prime of t, which is equal to inverse phi of t times f of t. What is f of t? F of t is this one. And inverse phi of t is this, what you just found. Multiply them together, it will give you this matrix, negative tangent square t and tangent t. So a little note here, when you multiply matrices together, do not switch their order, because the order for matrices matters. If you switch the order, it will give you a different answer over here, and it will affect your final answer. Okay, once you know u prime of t, the next step is to find the integral of u prime of t, which gives you vector u of t. Okay, so I integrated this one, it gave me this vector, and here's a note for it. So integral of tangent t is natural log of secant t, and integral of negative tangent square of t equals. So you cannot find the integral of tangent square of t directly, but you can use Trig identity. So tangent square is the same as negative tangent square is the same as 1 minus secant square. So the integral of 1 is t, integral of negative secant square is negative tangent. Okay, so I think it's simple. Now let's find our non-homogeneous part. So it is equal to phi of t times u of t. Okay, so here's your 5t, here's your u of t, and again multiply matrices together. Do not switch their order. Phi times u is not the same as u times phi. Okay, so keep in mind that. Doing this one gives you this matrix. So there's no way I can simplify this down. Okay, so let's keep it as it is. So for your final solution, it is equal to homogeneous part, which is this one, plus non-homogeneous part, which is this matrix. Okay, that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.